lessons. I'm recording it now. We'll record the lesson. The lesson will be available on YouTube, and the link to each day's lesson will be right here. So I'll take the same link and scroll. If you scroll down, you'll see a link to today's video recorded lesson. But I would encourage you to come. Just watching the lesson doesn't work because when you come, you can ask questions. You can ask me to repeat something. uh, if you don't understand something, I can help you. Watching a video lesson doesn't do that. But if you're a note taker, you don't have to take notes necessarily because everything is being recorded. One more thing, I have this free version of Zoom. So every to 30 minutes, it's going to tell me, your program will shut down. And if it kicks me out, and if I don't say goodbye properly, that means I'm going to come back again right away using the same link. I generally I can sense it when it's going to kick me out, and I'll say something like, let's get out of this session and rejoin right away. The class is not over. When the class will be over, I'll tell you that we'll call it today. If you have any questions, all those things. Now, in our class, when we do lecture in class, I give you some problems to try. And during online classes, it's not very easy to do. So I will be putting some problems here in additional problems done in class folder. If I think something is hard, today's lesson actually, interestingly enough, won't be that hard. It's actually pretty straightforward lesson. I will post problems here. If you want me to post something, you tell me, you email me, I will post it here. So the class will be a little shorter than usual class because it's very hard to talk for 1 hour and 15 minutes. It's hard for students to follow because you're not directly engaged. And maybe the classes will last about 45 minutes to 1 hour, just to let you know. Now, if you want me to stay here and help you, I'll be happy to do that. No problem. So, what we are gonna do today, again, you can I can't see you. I don't have a video camera here. If you want me to show your face, feel free to do so. If you want to interrupt anytime you can, unmute yourself and say, I don't understand this. Could you repeat that? Could you show us how to do number five? All those things are just fine. If for some reason I'm not showing you my screen, let me know. If you cannot hear me, let me know. If you see things are moving as if I'm explaining things, but you can't hear me, you have to let me know. Now, where are we? We are going to do 11.2, which is a fairly straightforward section. And the good news is you will be teaching some of those things. So it's not a bad section. There's not a lot of problems per se in this section. It's mostly a bunch of ideas that you're expected to know and teach. Okay. And when you take GAZE, you will see many of the things we will discuss today in your exam. So I'm going to start. This is 11.2. I'm going to wondering if I should take you to the book. I don't even think I need the book really. If you go to homework from text folder, click this. I added some problems from 11.2. I'll do some of them. I don't have to do all of them. I'll do a handful of problems from here, from your text, no problem. Not all because they're very repetitive. And once we are done with today's lecture, you should be able to do most of the problems in MATLAB. And here they are. I'll show you they're available to you. 11.2. Okay. So we mostly do chapter 11 and chapter 13. So we're making progress. We have been slowed down just a little bit. And another important thing, guys, when I'm hoping, hopefully we'll get back to campus next week. Now, we won't have our exam too right away. Once I know you guys have been through a lot, I'm going to make that assumption. It was rough in Valdosta as well. Most of you are probably were in Valdosta. I don't know. Uh, so when we go back to campus, we'll decide when you want to have the second exam. When we go back that day, we can do review and we can have exam the next day, or we can postpone it. and have it the week after. Ideally, it would be nice to have a face-to-face exam, not an online exam. But if for some reason, God forbid, if we can't go back to campus, things will have to be online. So be kind of prepared. Any questions, guys? Where we are, what we're doing, all those things. Okay, let's see. So I'm going to define a bunch of words, okay? And they are from 11.2. Now, I did put some documents in the notes folder. They're mostly about symmetry, but I'm going to define a few terms that most of you know. I will do it here. This is just a blank page where you can write and draw. Guys, polygon is a shape bounded by straight lines. And let's write it down somewhere. Polygon, polygon. So a triangle is an example of a polygon. Okay, I'm going to draw a triangle. Okay, this is a triangle. A triangle has three sides. This is a quadrilateral. I'm going to write it here. Quadrilateral. Okay. Actually, it might take me more than one class with 11.2. I'm not quite sure. And this is a triangle. Okay. Now, you can have a pentagon as your polygon can be a pentagon. A pentagon has five sides. Okay, it has exactly five sides and it's called a pentagon. Penta means five. Hexagon, tagon is seven, tagon is eight, the number sign, the stop sign. So these are polygons. Okay, if a polygon is regular, that means I'm going to save this here. If a polygon is regular, all four sides are the same. If a if it's a polygon and it's a triangle, all three sides are going to be the same. My picture may not be perfect, but I think you get the point. Okay. If a polygon is regular, all the sides are the same length. That's how we label them. I'm trying to tell you all the four sides are the same length and all the angles are going to be the same. If it's 90 degrees, we know in a square, it's 90 degrees. That's how I'm labeling it. In a triangle, this side, you can put one hatch mark, one, to say all the sides marked with one hatch mark are the same length. Here I put two hatch marks. Anything with two hatch marks have the same length, and the angles are also going to be the same. Okay, I'm going to write this down here. A regular polygon, a regular polygon has congruent sides and angles. Congruent means same. Okay. If the polygon is regular, then all its sides are the same length, all its angles are the same length. A square is a good example of a regular polygon with four sides. Triangle that has three sides, and if it's regular, it's called an equilateral triangle. Equilateral triangle. Okay. So again, equilateral triangle is a triangle whose sides are congruent, and of course, the angles are congruent as well. This is a square. I'm not going to define it. Now, speaking of triangles, you have more types of triangles. So the first one is equilateral. All sides are the same, all angles are the same. Let me grab a document here. That's going to help me a little bit. Now, I will be happy to upload it on BlazeView. I don't think it's there yet. Okay, I will upload it. Okay. So we'll define a few terms. Many of these terms are here. Okay, right here. An equilateral triangle has all sides congruent and all angles are congruent. All three sides are the same. Equilateral. The next one, the three types of triangles really, isosceles. Okay. Isosceles triangles are triangles with at least two sides congruent. Okay. In the first case, all three sides are congruent. That means at least two sides are congruent. In the second case, exactly two sides are congruent. The third side is smaller. So again, the word at least is very important. At least means two or more. So if it's an isosceles triangle, at least two sides are congruent. In that case, an equilateral triangle is also an isosceles triangle. And there is a question in your book, there is a question in MATLAB. It goes as follows. Are isosceles triangles, can isosceles triangles be equilateral? The answer is yes, because isosceles triangles need to have at least two sides congruent. If three sides are congruent, it satisfies the condition. There is a third one. There can be more triangles, and the third category is scalene. Scalene. A scalene triangle has no congruent sides. All three sides are of different lengths. QP is the shortest. QR seems to me to be the longest. PR is the medium side. Greater than PQ, less than QR. So these are the three triangles you want to be familiar with. Equilateral, scalene, and isosceles. Okay? One set of definitions that you're expected to know. I'm going to pause here just a little bit, okay? To see if you have any questions. Okay, guys, a couple of other definitions. Okay. So you have a polygon. Polygon has a number of sides, right? And you can have three sides, you can have four sides, you can have five sides. These are all closed sides, closed curves. And I'll give you an example. This is a closed curve. Where did I'm looking for? Okay. This is called a closed curve. And this is not a closed curve. It's acting a little funny. Excuse me, guys. Let me see why it won't do that. I'm going to delete this. I'm just going to use, this is not a closed curve. Get another word. It is in our definition, but I like to define closed and not closed. Don't say open. Okay. This is called not closed. Not closed. And this polygon is closed. Any polygon is closed. One more word. It's also in our definition packet that will be uploaded in the notes section. Another important term, guys, simple and not simple. If you have a curve that goes like this, If a curve crosses itself, I'm going to delete this. If any line or a curve, mostly we will be talking about straight lines, but occasionally you'll see a picture where you will have a curved line, okay? Like so. This is going to be a not simple, okay? Curve. This is going to be a simple curve. Let me draw it. So this is called simple. And don't say opposite of simple is complex. We will just say not simple. But because complex, the word complex has a different meaning in math. This whole section is about a bunch of words that you will be teaching. This is not simple. Okay, so we learned what's closed, what's not closed. We learned what's simple, what's not simple. Okay, so curves can be simple like this. Here's another example of a simple curve. This is a simple curve because it doesn't cross itself. This is an example of a simple curve because it doesn't cross itself. This crosses itself. This crosses itself. This is also closed because there are no loose ends. This is not closed. This is, you will just say not closed. So when you do the problems, even in your, whether it's from your book or from MATLAB, you will see they'll give you some pictures and they'll ask you, is it simple? Is it closed? Is it both? All those things. You should be able to handle them. They're very basic concepts. Now, we are going to talk about two more fancy terms. Okay, guys, I'm going to leave it here, leave this slide here. So this one is convex and concave. Concave and, oh, let's keep it separate. A curve or a polygon can be concave or convex. Okay, what's a concave? They're kind of similar. Concave shape has a dent in it. I'll tell you what I mean by a dent. So, get rid of this. I want my picture to be a little nicer. Excuse me. Okay, look at this shape. It is a polygon because it is bounded by straight lines. It's closed. It has no loose ends. All polygons are closed curves. Okay. And this is not a curve it's a simple curve. It doesn't cross itself. We're going to say it's concave because it has a dent. Dent. I keep it straight. The word cave kind of caves inside. That's how I keep it straight. Now, there's another definition of concave curve. If you connect two vertices, or take one, if you can find one pair of vertices, and if you connect them, this is called a diagonal. I'm going to change its color to red. This diagonal will stay completely outside the polygon. If you can construct one diagonal that stays outside the polygon, your polygon is concave. It will have a dent. Right. The concave, convex ones, you won't be able to do it with this. You won't be able to connect two points, two vertices, and make the diagonal stay outside the polygon. And it has no dents. So this is convex. This is a concave polygon. This is a convex polygon. You can have a concave pentagon. I'll show you. I am giving you quadrilaterals there, but you can have a concave pentagon. 1, 2, 3. One, two, three, four. 5. Okay, this has 5 sides. One, two, three, four, five, and this has a dent. Okay, if you connect, if you connect these points, you will be able to form a diagonal that stays completely out of your pentagon. Now, let me pause here and ask you if you understand what we mean by concave and what we mean by convex. Let me see if you have any questions. Feel free to unmute yourself and ask. There are lots of problems, questions about concave and convex. Okay, so a little bit of recap. Okay, these are some of the words we learned today. Okay, simple. Simple curve means the curve doesn't cross itself, and the opposite of simple is not simple. Closed. Closed curves don't have loose ends, and the opposite of closed is not closed. We also learned concave. I'm just going to put it here, convex here. Concave. Okay, we learned concave. Concave means the polygon has a dent, and opposite of concave is convex. So we learned these three fancy words. Okay, I think there is a problem like this. So if this shape, they'll ask you something like this. If this shape, is this shape concave or convex? There is a dent. I would say it's concave. And when it comes to polygon, we looked at the diagonals. But for this one, you can define it also by doing, you can define it also in this manner. You're going to take, if you can take 2 points inside the shape, I'm going to take 1 point here and 1 point here. And if you can connect it by a line, and if part of the line or the whole line stays outside the polygon, it is a polygon that's concave. It's a shape that's concave. Okay. Again, it'll have to have a dent. I can clearly see the dent here, but some people don't like the definition in terms of the dent. They will say if you can take 2 points inside the shape and if you connect them, if your line at least partially stays out, it is a concave shape. So you'll get problems like this. So everything we said about concave and convex, we said it in the context of polygons, but they also work in terms of other shapes as well. Okay. Any question? I'm going to pause here just a little bit. All right, guys. Okay, the only problem we have in this section that's kind of mathematical is this, and we're going to do it. Okay, where you'll get a number as an answer. Okay, so let's say I'm gonna take my, well, let me take a nicer shape. Number of diagonals of a polygon. They'll ask you to find the number of diagonals of a polygon. What does that mean? Well, diagonal is this. If you take 2 points and connect them by a line, that line is called 2 points of your polygon, and connect them by a line, that line is called a diagonal or a diagonal of the polygon you're talking about. Now, you may be able to connect this point to this point by a line, and that line is going to be this line. We don't call it a diagonal because it is a side. So sides cannot be diagonal. So now we can say what's a diagonal? If you connect a point of a polygon not to its neighbor. This guy is neighbor of this. This is your point. You're connecting something to it. This is not going to work because this is going to connect, make a side. This point will not work because if you connect the this point to this point, you're going to get a side. Anything else will be okay. So connecting this point to this point will give you a diagonal. Connecting this point to this point will give you a diagonal. Make sure they're red. Connecting this point to this point will give you a diagonal. So one more word, diagonal, how to construct diagonals of a polygon. Now, what they really want to know is that how many diagonals can you construct? Now I'm going to get out of this. So I'm going to do it kind of conceptually, guys, okay? So there could be a problem. They'll say, I have a five-sided polygon. How many diagonals can I construct? So look at the five sides, guys. I can draw all together. I have 5 points. From each point, I can only draw 3 diagonals because this point cannot be connected to this. Out of 5, actually 2, my bad. Okay, you cannot connect a point to itself. You cannot connect a point to its 2 neighbors. So out of 5, 3 are gone. There are 2 left. So from this point, you can draw 2 diagonals. From this point, you can also draw 2 diagonals. From this point, you can draw 2 diagonals. From this point, you can also draw 2 diagonals. From this point, you can draw 2 diagonals. I'm going to prove it to you right now. 1, 2. My drawing won't be perfect because it's being done on the computer. Take a look. I have drawn 2 diagonals from each point. If you have a pentagon has 5 corners, 5 vertices. We say they're vertices. Okay, let me write it down. Vertex is singular, vertices is plural. Okay, through each point, you can draw 2 diagonals, singular and plural. All right, so I have 2 out of this, 2 out of this. So shouldn't the answer be number of diagonals? Number of diagonals. Shouldn't that be 5 times 10? 5 times 2? But that's not the case. Count it. If you carefully count, you get 1, 2, 3, 4, 5. We're getting 5. So what's going on? What kind of mistake am I making? I have to divide this by 2. I'll tell you why. Let me do it nicely. The number of diagonals will be, there are 5 points times your 2. Each point will be connected to, or through each point, 2 diagonals can come out, but you have to divide it by 2. And I'm going to tell you why. And the answer will be 5. Look, this diagonal belongs to 2 points. So this diagonal will be counted twice if you don't divide it by 2. Same is true for each of the other diagonals. This diagonal will be counted twice. One says this point's diagonal, one says this point's diagonal. So you better divide your answer by 2. Same thing goes for this one. This diagonal will be counted twice if you just multiply 5 by 2, because this diagonal is counted as if it belongs to this point and also as if it belongs to this point. So every diagonal is being counted twice. So to fix that mistake, you divide it by 2. I'm going to pause here just a little bit, guys. Just a little bit. See if you have any questions. Okay, guys, let's do one more. One more problem. Okay. Let me take another polygon. Let's make it an octagon. That means 8. Okay. This is not the best octagon, but it's an octagon. I'm not going to draw all the diagonals. You're going to see that they are going to be overwhelmingly large. Okay. So I am going to claim through each point an octagon has 8 vertices. I'm going to write down, we are talking about octagons, octagons, or 8 gons. Okay. Okay. Here's the deal, guys. This computer will kick me out in 4 minutes. Okay, so let me switch and let me start this problem in our next video session. I'm jumping out of this session, coming back right away. Don't go anywhere. We are still having our class. So I'll see you soon in a second, okay? Bye-bye, guys. Come back really quickly. We're jumping out and coming back in.